Hey guys, tonight we drift into the kind of cosmic mystery that makes even seasoned astronomers sit up a little straighter at their telescopes. Out past Neptune's faint glimmer, something has appeared where nothing should be. A planet massive, cold, and somehow ownerless slides through the darkness like an uninvited guest at the universe's most exclusive dinner party. You probably won't survive this one if you try to explain it at brunch tomorrow, but don't worry. Tonight you're safe under your blanket and all you have to orbit is your pillow. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And tell me in the comments where you're listening from and what time it is there right now. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The first alert came from a graduate student in Chile, or maybe from an algorithm that didn't care about names. It noticed a dim, wandering object slipping through archival data from the Atacama Array. The pattern was wrong. Too slow for a comet, too fast for a Kuiper Belt object. When the observatory's main system cross-checked orbital predictions, it spat out an impossible result: no orbit found. You're there imagined behind the screens, hearing the hum of cooling fans and the rattle of coffee cups. Outside, the desert sky burns with a billion pinpricks of clarity. Inside, a line of code has just told humanity that something the size of a small planet is moving through the solar system without following anyone's rules. They name it provisionally Object 3I Atlas, because that's what bureaucracies do when faced with cosmic absurdity. 3I means interstellar, the third of its kind ever found after the cigar-shaped Oumuamua and the comet Borisov. But this one is different. It's not a visitor passing through, it's behaving like a resident who forgot their address. The first nights of observation are a blur of disbelief. Telescopes across Hawaii, Arizona and Tenerife all confirm the same thing. Its path curves slightly, but doesn't close. No perihelion, no aphelion. Just a long, lazy drift across the darkness as if gravity itself had misplaced the file on this world. Scientists joke nervously that it's the planet that forgot its orbit. Still, curiosity wins when 3I Atlas. The spacecraft, not the object, is commanded to pivot its sensor array toward that region. You imagine the slow mechanical ballet of motors and mirrors, the hum of gyroscopes, the faint electric chatter between deep space transmitters. Somewhere on Earth a control room falls silent. The image feed begins a grey sphere, faintly glowing in reflected starlight. At first glance it looks ordinary, a frozen gas giant perhaps like Neptune's quiet cousin. But the more they zoom in, the stranger it becomes. Its colour shifts subtly frame by frame like oil on water, and behind it the background stars appear to bend ever so slightly, as though space itself is sighing around its presence. Historically, humans have always reacted the same way to anomalies: first laughter, then fear, then conferences. Within days, astrophysicists are arguing over gravitational models. Some call it a data glitch, others a hint of new physics. One bold soul quotes Einstein's line about insanity, doing the same math over and over, and expecting the universe to care. A week later, the European Southern Observatory confirms it. The object has mass comparable to Mars, yet refuses to orbit the Sun or any known centre of gravity. It moves as if bound to a ghost. Perhaps it's tethered to a dark matter clump, one researcher suggests. Or maybe another whispers over lukewarm coffee it's tethered to memory itself. That last remark makes everyone laugh, but not for long. Because as 3 Atlas continues its watch, the planet's faint glow begins to pulse slowly, rhythmically, like the beat of something alive. Scientists still argue whether the flicker is reflection or emission, but one thing's certain: the timing matches no natural rotation known. It's as though the world itself is blinking, deciding when to exist. At the next morning's press briefing, the lead astronomer tries to stay composed. It's likely a rogue planet captured temporarily by our sun's outer influence, she says. But her voice wavers on likely. She knows the math says otherwise. You picture yourself outside looking up, trying to imagine a planet with no parent star. No sunrise, no year, just endless night and orphan wandering the corridors of gravity. And for a moment you feel the quiet terror of that idea that a world can forget where it belongs and still keep moving. By the time midnight rolls across your own sky, news feeds are calling it the lost planet. Memes flood the internet, one shows it with a suitcase, another with a 404 orbit not found sign. Even NASA tweets a wry emoji, proving once again that humour is humanity's favourite defence against cosmic dread. But in the still hours between notifications, you can almost hear the deeper hum, the ancient awe of realising that the universe still hides surprises. It's the same feeling sailors once had when they found islands unmarked on maps. The same trembling curiosity that made Galileo aim his telescope toward Jupiter and mutter, "I have found more worlds." Somewhere, maybe in a lab you'll never visit, someone looks up from a monitor and whispers, "What if it's not lost at all?" Because maybe forgetting isn't failure. Maybe it's the universe's way of starting again. You wake again inside the drifting silence of deep space. Out there beyond Neptune's far-flung dominion, the lost planet glides like a thought that refuses to settle. Telescopes keep their unblinking eyes fixed on it, while supercomputers sigh under terabytes of equations that refuse to converge. You can almost imagine the frustration of those late-night scientists, half human, half caffeine, rearranging orbits that simply won't exist. Its motion breaks every rule. A planet should curve, fall, repeat, obey its star like a loyal moonhound tethered by gravity's leash. But this one moves straight, almost arrogantly, so cutting through heliocentric geometry like a protest. It neither plunges inward nor drifts outward. Instead, it keeps a patient distance as though remembering something long forgotten and refusing to rejoin. In those sleepless control rooms, equations multiply. The numbers suggest it's not bound to the sun nor entirely free from it. An object this heavy, moving this slow, should have fallen into orbit or escaped entirely. But no, it lingers. Imagine throwing a ball that never comes down but never flies away either, just floats mid-air, defying your arm and Newton alike. That's the predicament. And there you are, somewhere in that mental observatory, sipping your cosmic cocoa and watching the math misbehave. The first historical parallel everyone digs up is the case of Neptune itself. Back in the 1840s, astronomers noticed Uranus wobbling slightly off course. Its orbit wasn't quite right, so mathematicians used that error to predict an unseen neighbour. The prediction worked. Neptune appeared exactly where math said it would be. It was one of humanity's great moments of celestial detective work, numbers summoning a new world. But this time the numbers don't summon anything, they dissolve. Every attempt to map the rogue's motion fails. If you feed the data into simulation software, the digital solar system begins to unravel like yarn planets veer off the sun flickers, and after a few seconds the entire simulation crashes. Too many undefined variables, the error message reads. A polite way of saying the universe disagrees with your spreadsheet. Still the search continues. 3i Atlas adjusts its mirrors and instruments its onboard AI, running millions of predictive models. Somewhere in that computational storm, a faint pattern emerges almost like memory. It seems the planet follows a loop so large it can't be seen from our narrow perspective. Picture drawing a circle so big that if you stood on it, it would look like a straight line. Maybe that's what's happening here. The orbit exists, but it's ancient, centuries long, maybe millennia. Or maybe whispers a more romantic corner of your mind it's not orbiting anything. Maybe it once belonged to a different star entirely. A solar emigrant that left home after its sun died. The galaxy is full of such exiles. Scientists estimate billions of rogue planets drift between stars cold and lonely, each one a failed solar system carrying geological memories of its former life. This one, though, feels special. Its path isn't random. When researchers plot its trajectory backward in time, something peculiar happens. About 12,000 years ago, it passes eerily close to where Earth's orbit would have been close enough to influence tides, maybe even climate. And that's when someone notices an old Sumerian tablet describing a wandering eye that brushed the heavens and turned rivers to silver. Scholars still argue whether this refers to a comet myth or mass hallucination fueled by ancient beer. But the coincidence is delicious. As always, fringe theorists seize the stage. One astrophysicist, an old rebel who still writes with fountain pens, claims the object might be a remnant of Theia, a hypothetical planet that collided with Earth 4.5 billion years ago, birthing the moon. What if a piece survived, he muses. What if Theia forgot it was supposed to die? His colleagues roll their eyes, but secretly they love it. Science without imagination is just accounting with extra decimals. Meanwhile, 3 Atlas keeps watching. Its onboard sensors detect subtle spectral lines in the reflected sunlight signatures of frozen methane, ammonia, and something else that doesn't belong. A chemical fingerprint too complex for nature's lazy randomness. Maybe a pollutant, maybe an artifact. The debate rekindles like a campfire in the void. As you listen somewhere inside the narrative, you can feel the mood shift from ridicule to reverence. Humanity loves a riddle. The harder it is to solve, the more sacred it becomes. You picture the late-night messages between observatories reconfirming data. No orbit detected. Planet appears stable. Stable in what sense, someone replies. Existentially, emotionally. By week 3, the headlines have settled into uneasy fascination. The lost planet becomes a fixture of late-night talk shows, conspiracy podcasts, and those TikTok explainers, where a guy with glowing blue lights behind him insists it's proof of alien planetary drives. You smile, because of course he does. And yet in a quiet corner of reality, a different tone emerges. A senior cosmologist gives an interview voice hushed. If a planet can forget its orbit, she says, then maybe the laws we think of as permanent are just habits of the universe, habits it can unlearn. The phrase lingers like static in your mind. Habits of the universe. You picture gravity as an old pianist repeating the same melody for billions of years and suddenly deciding to improvise. Maybe 3i Atlas has just caught the cosmos in one of those moments of creative jazz. Outside in your own world, the fan hums steadily. The air feels lighter somehow. You think of all the patterns humans cling to, routines, expectations, orbits of the soul, and how fragile they are. Maybe this drifting planet isn't an error. Maybe it's a mirror. And so the night deepens and 3 Atlas keeps staring into the dark, trying to remember how a planet can move forever, unanchored yet unlost. The longer humanity stares at the nameless world, the more personal the mystery becomes. You can almost feel the collective exhale of a planet our planet as we look out at that other one and see a reflection of our own uncertainty. Every civilization has drawn meaning from the stars, but this time the stars are looking back with a question mark. The committees gather as they always do when wonder needs an acronym. Someone insists it can't stay 3R 2025QX. It's too sterile, too clinical, like naming a dream after its filing number. Astronomers are sentimental creatures no matter how many equations they hide behind. So they open the naming debate. The rules are strict. Anything mythological not already in use, ideally symbolic of its peculiar nature. You lean in amused by the ritual. There's always the one person who suggests Planet McPlanetface, and always the one who threatens to resign if that wins. Another proposes Lethe, the Greek river of forgetfulness that washed away memory from the souls of the dead. It fits too perfectly the planet that forgot its orbit. But then someone else mentions that Lethe was also a goddess, not just a river, and suddenly the discussion tilts into poetry. Across time zones, messages flicker through encrypted channels, Lethe confirmed as provisional codename. It sounds soft, melancholy, almost human. A world named after forgetting. But the myth runs deeper than most people realize. In ancient Greek cosmology, Lethe wasn't punishment, it was mercy. Souls drank from her waters to let go of pain before reincarnation. You start to wonder if this planet truly lost its orbit. Maybe it wasn't abandoned. Maybe it chose to forget, to shed gravitational burdens and wander free. Of course, scientists laugh at such thoughts during daylight. But late at night in those quiet observatories, where only the coffee machine hums, even they feel the tug of myth. Humanity's oldest impulse is to wrap science in story, to make the cold equations glow with meaning. It's how Newton's apple became legend, and how Einstein's train rides turned into metaphors for relativity. Meanwhile, 3i Atlas records something unexpected. The planet's reflected light contains faint absorption bands not matching any known element. Not alien exactly, just unfiled. Could be unknown isotopes, one chemist mutters. Could be instrument noise, another says too quickly. Scientists still argue whether it's real, but the data sits stubbornly consistent. For the first time in months, the 3i Atlas's onboard AI flags a priority alert possible atmospheric anomaly detected. The AI has a sense of humour. It attaches a Shakespeare quote from its library, "What's past is prologue." The next data transmission paints the image in more detail. Wisps of ammonia clouds swirl across a glass-blue atmosphere. Lightning flickers beneath layers of methane frost. But the storms move in arcs that don't make sense. They spiral outward as if blown from the inside out. And each rotation ends with a flicker of ultraviolet light regular as a heartbeat. The astronomers fall silent. One finally whispers, "That's periodic." Another murmurs, almost like a beacon. It's absurd, of course. Planets don't send messages, yet even absurdities have gravitational pull. Soon every think tank from SETI to the European Astrobiology Network is cross-referencing pulse intervals. Some find echoes in the radio background, others claim coincidence. The most poetic interpretation comes from a historian of science who says, if the universe wanted to write us a riddle, it would use its oldest language light. You imagine her saying that under dim studio lighting, her eyes bright with quiet mischief, the kind that keeps humanity curious even in the face of nothingness. Meanwhile, the public grows fascinated. Artists post digital renderings of Lethe glowing faintly blue, her storms like slow fireworks across a sapphire sea. One popular animation shows the planet drifting through space, trailing ribbons of mist that dissolve into constellations. It's oddly soothing proof that even chaos can look serene when slowed down. Somewhere in all this, you catch yourself wondering what it feels like to live on a world without sunrise. No orbit means no day, no year. Time, there would have no rhythm, just endless twilight. You'd have to invent your own cycles, your own rituals of light and dark. Maybe that's what we humans are doing every day, pretending our clocks and calendars mean something cosmic. One of the more fringe astrophysicists who secretly keeps a tarot deck in her lab drawer writes an editorial for Scientific American. She calls Lethe a mirror for consciousness itself, an object that has escaped predictable recurrence. It gets her invited onto a few podcasts, then quietly reassigned to grant writing duty. Yet her phrase sticks. Escaped predictable recurrence. Isn't that what all of us crave at some level, to step off the loop of habit, gravity and expectation, and simply float? As weeks pass, the data grows richer and the mystery deepens. The planet's mass fluctuates slightly between readings, as if its density shifts in subtle pulses. Instruments confirm it's not measurement error. Something inside Lethe moves, expands, contracts, like the breathing of a stone giant. Somewhere between awe and exhaustion, a technician mutters, maybe it's just tired of being consistent. Everyone laughs, but there's a strange comfort in that thought. A planet sighing in the dark, tired of obeying. In the archives, you find an echo of another moment like this. Back in 1972, when Pioneer 10 first sent back images of Jupiter, scientists noticed a plasma bulge that made no sense. For years, they argued whether it was data corruption or real physics. Turns out it was both a real phenomenon that didn't fit their models yet. A reminder that sometimes reality is the glitch. That's what Lethe feels like, a cosmic glitch that refuses to crash the system. Instead, it hums gently, whispering, "I exist outside your categories." And you, listener, half asleep and half awake, realize that maybe the story isn't just about a planet at all. Maybe it's about how knowledge itself forgets its orbit, sometimes spinning out, searching for something new to circle. The fan hums again. You exhale slowly, letting your own thoughts drift like that lonely blue sphere beyond Neptune, luminous, unanchored, and for tonight, at least free. The equations refuse to behave. By now, every major observatory on Earth has joined the Chase Hubble Subaru Keck, even the reactivated James Webb, all staring at the same speck of light that mocks every known law of celestial obedience. You picture the control room's dim blue screens, quiet murmurs that strange atmosphere halfway between worship and debugging. Someone has drawn a cartoon on the whiteboard of Newton, holding his apple upside down, frowning. You drift there with them, the invisible observer floating between minds and monitors. A graduate intern squints at her display, tracing the planet's path in pale green. The line should curve, but it doesn't. Instead, it snakes oddly like a loose thread in space-time. That can't be right, she murmurs. The supervisor leans over. Plot it again. She does. The result is the same. The universe shrugs. This is the gravity problem, the one that keeps theorists awake at 3 a.m., chewing on pens and existential dread. How does a planet ignore its star gravity as supposed to be loyal? It doesn't just ghost you. Every atom should respond to the same pull, the same fabric of space-time Einstein once described as geometry that tells matter how to move. But Lethe, our forgetful wanderer, moves as though geometry itself had folded her permission slip. The mainstream explanation arrives quickly. Perhaps a hidden mass is nearby, a clump of dark matter shaping invisible curves. Dark matter, of course, is science's favourite placeholder, for we don't know yet. It's the cosmic equivalent of writing on your homework and still getting partial credit. Yet the models still fail. The supposed dark matter density required would have to be enormous enough to bend starlight, yet no gravitational lensing appears. One physicist jokes maybe the dark matter is shy. Another adds, or maybe the planet is gaslighting us. A ripple of laughter crosses the lab, the humankind that happens when truth feels too big to fit inside language. Historically, this isn't new. Every few centuries, humanity bumps into a wall of paradox. Mercury once defied Newton too, until Einstein's relativity rewrote the script. Maybe Lethe is our new Mercury, says Dr. Ortiz from Caltech. Maybe she's whispering the next revision of gravity. Scientists still argue whether that's optimism or heresy. Three-way Atlas, orbiting serenely far from Earth's noise, collects its own quiet evidence. Its spectrometer senses a faint warping of space-time around the planet, but not in the way a black hole would. Instead of pulling light inward, Lethe seems to tilt it sideways like a lens with a mischievous grin. The photons bend just enough to confuse, not enough to explain. You imagine the universe watching this scene like a teacher, watching children argue over crayons, amused, patient, maybe even proud. Somewhere a new theory is waiting, tapping its foot. The oddest data comes not from 3i Atlas, but from a small observatory in Finland. During a clear polar night, an amateur astronomer named Thule captures images showing Lethe's apparent position, shifting ever so slightly by a few arcseconds against the predicted path. Parallax error, skeptics say, but Thule double-checks using an ancient star catalogue, and her numbers hold. The planet isn't where anyone says it should be. It's where it wants to be. And in that disobedience there's something hauntingly beautiful. A world rewriting Newton in real time. To calm the chaos, NASA convenes a digital symposium titled The Non-Orbital Object Phenomenon Toward a Framework. The name is as boring as possible intentionally because the last thing the agency wants is another media frenzy about the haunted planet. The meeting drags on for 14 hours. Equations dance across holographic displays. Finally, one weary participant says, "What if gravity has memory?" The room stills. He explains perhaps the planet's mass once orbited elsewhere, and space-time still remembers that older pattern, like grooves in a record. Even after leaving its star, it continues moving along the ghost of its past orbit momentum haunted by memory. A kind of gravitational nostalgia, he says. Everyone laughs again, but less dismissively this time. The phrase gravitational nostalgia appears in 2 academic papers within a week. One journalist turns it into a headline, "The universe misses its exes too." Meanwhile, 3i Atlas records something new. The planet's clouds shift suddenly, forming massive hexagonal storms eerily similar to the one at Saturn's North Pole. The pattern lasts exactly 6 hours, then dissolves, leaving a faint electromagnetic echo. The signal's frequency matches almost perfectly the Schumann resonance of Earth's own atmosphere. Coincidence? Scientists still argue whether that's even possible. If you're keeping score, that's now 2 mysteries stacked on one another in possible motion and sympathetic resonance. In your mind's eye, you drift closer. The planet fills your vision blue-grey streaked with lightning. You imagine hovering just above its stratosphere where hydrogen wisps into aurora that shimmer like underwater light. Beneath you, clouds churn slowly, vast as continents. You can almost hear it breathing slow, deep planetary breaths. A sudden thought slips through your drowsy curiosity. What if Lethe isn't breaking gravity but teaching it? Like a dancer improvising so gracefully that you realize maybe you've misunderstood the choreography all along. You smile. Somewhere in the background, your fan hums a low, faithful note, your own private resonance echoing the planet's mysterious pulse. It's late now. The scientists keep running simulations that collapse after 3 seconds. Equations drift on screens like constellations of confusion. The AI aboard 3i Atlas compiles the anomalies into one understated report: gravitational parameters inconsistent with standard model. Suggest new framework. You imagine the quiet triumph behind that understatement. Somewhere Newton's ghost adjusts his wig. Einstein pours another cup of cosmic coffee, and you, still floating between them, can't help but laugh softly, because even in the grandest mysteries, the universe keeps its sense of humour. After all, maybe gravity was never about falling. Maybe it was always about remembering how to come home. You'd think that by now humanity would have learned to stop being surprised by the universe. But then 3i Atlas sends back its first close-up images, and surprise becomes something sacred again. The transmission takes hours to decode compressed light, filtered through billions of kilometers of silence. When the first frame resolves, a low gasp ripples across the control room in Pasadena. You see it too in your mind, a grey-blue sphere wrapped in thread-like clouds, storm bands twisting like ribbons of glass. Lightning flickers underneath, illuminating translucent layers that shift between turquoise and silver. It looks both alive and frozen, a paradox suspended in space. The engineers amplify the image. Beneath the outer haze, darker bands form fractal spirals, storm-shaped like the cross-sections of seashells. Their centres aren't random. They follow a pattern. Each vortex sits at precise golden ratio intervals along the latitude lines, as though the planet had been painted by Fibonacci himself. Someone mutters, "That's artistic." Another whispers, "That's impossible." You lean closer, caught in the same hypnotic pull that once made people stare at Jupiter's great red spot for hours, or the moon's pockmarked face for stories of rabbits and lovers. Science and myth have always shared that one thing: both begin with staring too long. The 3i Atlas onboard spectrometer scans deeper. Its readings translate into colour, temperature, motion. You can almost feel the rhythm of the data, like the heartbeat of an ancient creature. Each storm moves with clockwork precision, yet none of them interact. They spin independently, refusing to collide neighbours in perfect solitude. Stable vortex systems shouldn't behave like that, says Dr. Imani Endow, one of the mission physicists. They should merge, dissipate, decay. She trails off. On the monitor, Lethe's storms continue turning untouched by time. Scientists still argue whether they're seeing meteorology or mechanism. Some propose crystalline cloud structures acting as electromagnetic regulators, like a planetary-sized capacitor, discharging energy through storms. Others think it's an illusion caused by layered rotation speeds. Either way, it shouldn't look this intentional. The press releases, of course, stay cautious. Atmospheric dynamics remain under investigation. But online, the memes evolve faster than the models. One popular thread calls it the clockwork sea. Another paints Lethe as a cosmic watchmaker who forgot its purpose but kept ticking anyway. Meanwhile, you're somewhere between laughter and awe. A planet that forgot its orbit but remembered geometry, there's poetry in that. It's like a dancer who lost the stage but kept the choreography. A few days later, 3i Atlas sends thermal maps. They reveal another anomaly: the planet's outer layers sit near absolute zero, colder than deep space itself. Yet infrared sensors detect faint warmth beneath the clouds. A slow internal glow pulsing from within, not powered by a sun. Residual formation heat, says one analyst. Or radioactive decay. But the numbers don't fit. The glow is too rhythmic, too stable. Not fading, not random. You imagine floating above it, seeing that light shimmer through the clouds, like breath beneath ice. It's almost beautiful enough to make you forget how wrong it is. Every discovery breeds more questions. Why does Lethe have no visible impact craters? No signs of asteroid collisions? The solar outskirts are littered with debris, yet its surface looks pristine. Either it's protected by an invisible field, or someone or something cleaned it up. Theories multiply. Could it be coated in self-healing ice, or nanostructured dust? Maybe it's just lucky. Luck, of course, isn't a scientific variable, but that doesn't stop anyone from whispering it. There's a historical parallel here too. In 1610, Galileo looked through his crude telescope and saw what he called planetary ears, the rings of Saturn blurred into lobes by primitive optics. For weeks, scholars debated whether Saturn had attachments, wings, or companions. They didn't know what they were seeing, so they invented possibilities. That's where we are again. Even with billion-dollar telescopes, we're still peering through fog naming shapes we barely understand. And yet, the fog is hypnotic. As more data pours in, the storm patterns start repeating identical sequences appearing weeks apart. Someone runs a cross-correlation analysis and discovers a 19.6-hour cycle, matching no known rotational period. The storms are blinking as if transmitting something. The pattern, when converted into audio frequencies, produces a soft hum, low resonant, strangely soothing. A sound engineer plays it on a live stream. Millions tune in to hear what they call Lethe's lullaby. It becomes viral meditation material. You can almost imagine insomniacs falling asleep to the pulse of a world that itself refuses to rest. But beneath the serenity there's tension. The hum grows fainter with each transmission, as if the planet is retreating into silence. When 3i Atlas boosts signal gain, the image flickers. One scientist swears she sees structures' geometric patterns beneath the clouds. Artifacts her supervisor insists. Compression noise. Still, she saves the image anyway. In it, if you squint, there's something that looks suspiciously like symmetry, a hexagonal lattice faintly glowing deep inside the atmosphere. You let that image drift through your mind as you breathe slowly. A lattice beneath the storms, a heartbeat beneath the cold, a memory beneath the forgetting. And as your thoughts begin to quiet, you realize something almost funny. The deeper humanity looks into Lethe, the more it resembles us, chaotic on the surface, yet full of quiet order just below the clouds. Maybe every lost planet carries a little human echo, wandering contradictory and still somehow beautiful. You drift with 3i Atlas, now a silent passenger riding beside it, as it keeps its glassy sensors fixed on the cold enigma ahead. The hum of its instruments is steady, no drama, no haste, just the patient breathing of a machine built for wonder. The object Lethe fills the viewport. It glows faintly from within, the way old embers do long after the fire has died. That glow shouldn't exist. At its distance from the sun, sunlight is nearly meaningless. The thermal maps confirm it again. Lethe is colder than Pluto on the outside, but somehow 20 degrees warmer at its core. Residual heat, one team says like a mantra they no longer believe. Or chemical decay. But the heat signature pulses not randomly, but in cycles of precisely 9.3 hours. That regularity doesn't belong to geology. You imagine floating just above its atmosphere, watching the faint inner shimmer leak upward through bands of crystal blue clouds. Every pulse makes the mist ripple outward like breath on glass. The spacecraft's sensors translate it into sound, low, almost subsonic tones. You don't so much hear them as feel them in your chest like distant thunder muffled by snow. It reminds you of Earth's own oddities. Remember how deep in the Pacific hydrothermal vents spout boiling water from the planet's coldest trenches? Life grows there, blind, fragile, luminous. Maybe Lethe has its own vents beneath the ice, its own secret chemistry, breathing warmth into the void. Scientists still argue whether that warmth could sustain anything more complicated than molecules. But hope like radiation travels far. When the data reaches Earth, debate explodes. Some say internal pressure might trigger slow nuclear reactions, a natural fission core like Jupiter's. Others think tidal friction could explain it, though that's funny, because Lethe orbits nothing. Tidal friction with what a physicist snorts. With nostalgia. That line makes it into late-night monologues, which makes the scientist hate the comedians, which makes the comedians feel secretly proud. Meanwhile, the spectral analysis grows weirder. The heat pulse aligns with faint electromagnetic bursts, tiny flares that ride outward through space faint enough to be almost quantum noise. One intern, half-joking, runs the intervals through a musical notation program. The result, a repeating harmonic pattern of FAE. 3 notes, over and over. She titles the file "The Planet Plays FAE." It becomes an inside joke in the lab, though. Someone later remembers that in German musical code those letters stand for frei aber einsam, free but lonely. Coincidence, of course, but a poetic one. Outside of the jokes, the deeper implication crawls in like slow frost. The bursts are too rhythmic to be random, too faint to be artificial in any obvious sense. Somewhere between physics and poetry, the question arises, can a planet remember its heartbeat? If the outer layers are dead ice, then something deeper must be stirring. 3i Atlas adjusts its magnetometers. The readings show flux patterns unlike any known planet. Instead of a simple dipole field like Earth's, Lethe's magnetic lines twist inward, looping into themselves like Mobius strips. The result is a field that traps its own radiation recycling energy endlessly. A self-heating feedback loop, one that could in theory keep a planet warm for billions of years without sunlight. That shouldn't work, yet here it is, humming quietly across the void. You think back to 1979 when Voyager 1 passed by Jupiter and discovered Eo's volcanoes. Before that, no one believed a moon could be geologically active so far from the sun. We were wrong before, says Dr. Nadur, half smiling. We can be wrong again. Lethe seems to thrive on being the exception. Each new scan reveals deeper contradictions. Its density suggests a rocky core, but its spectral lines show metallic hydrogen, something that usually forms only under gas giant pressures. It's as if a rocky planet learned gas giant tricks, a chimera of planetary physics stitched together by some long-forgotten cosmic event. When Through Atlas sends a radar pulse, something unexpected happens. The echo comes back cleaner than it should. Smooth, polished, almost like it's bouncing off a hollow. Subsurface void detected, the report reads. A cavern hundreds of kilometers wide reflecting radio waves like metal. That's nonsense, someone mutters. Planets don't have caverns, but the data is consistent. If Lethe were made of rock and ice alone, the radar return would scatter. Instead, it sings. The anomaly sparks every kind of theory. Some claim it's a massive geode of iron crystal. Others whisper it's an ancient impact bubble sealed by pressure. One romantic soul writes an entire essay titled "The Heartbeat Beneath the Ice, a Planet's Secret Furnace." It trends for 3 days, inspiring art and conspiracy videos alike. At the far edge of NASA's conference room, a quiet voice asks, What if it's not a void? What if it's a mechanism? The question hangs there trembling between brilliance and madness, and for a moment everyone imagines it an enormous machine frozen and forgotten, still exhaling heat after eons of silence. A world not born but built. The thought doesn't last long. Rational minds reassert themselves. No evidence, someone says. Correlation, not causation. The meeting adjourns. But that one phrase stays lodged in your imagination. A world built, not born. You close your eyes and picture it again, the glow pulsing beneath its icy shell, the invisible hum travelling through miles of frozen hydrogen. Maybe you can almost feel the warmth of it through the darkness, a small defiance against entropy itself. And suddenly that glow feels familiar. Not alien, not distant, just human. The same stubborn light that refuses to go out even when the cold insists it should. The next surprise doesn't come from light or heat or colour, but from sound. Well, not sound in the human sense. Space is silent, of course, unless you count the electromagnetic murmur of charged particles, those invisible ripples that telescopes translate into data, which we then translate into meaning. Somewhere along that chain mystery always sneaks in. The 3i Atlas array begins picking up irregular bursts in the radio spectrum, brief whispering pulses emerging from the planet's magnetosphere. At first, the engineers dismissed them as cosmic interference, but then they noticed the rhythm. Each burst arrives at roughly 4.7-second intervals, steady, patient, almost polite. You imagine the engineers leaning closer to their speakers, tired faces lit by blue screens, listening to static as though it might confess something. The pulses persist. After 6 hours, they form a pattern, long, short, short, long. A graduate intern laughs nervously. Looks like Morse code, she jokes. Her supervisor snorts, "Yeah, what's it saying? SOS." A few keystrokes later, the answer appears on her monitor. The sequence translates imperfectly to something that could be read as hello. Everyone laughs, of course. They have to. Laughter is a shield against the impossible. But the rhythm continues unwavering. Even after instruments recalibrate, even after accounting for reflection, echoes and cosmic noise, the pulses keep whispering through the void. Scientists still argue whether the pattern is deliberate. It could be resonance harmonics within the magnetic field, one says. Could be ionized particles bouncing between poles. But deep down, no one believes that completely. Not after the 19.6-hour storm cycle, not after the steady heartbeat glow. The planet's coincidences are piling up like winks. SETI takes notice. They dust off protocols written decades ago, procedures for potential technosignature detection. Somewhere in the bureaucracy, a memo with redacted sections begins its slow crawl through NASA's internal servers. The title line reads simply, "Possible non-natural periodicity, detected from object 3i Atlas Lethe." You can picture the press officer rehearsing their eventual statement. No evidence of intelligence, but the phenomenon remains under review. It's the same line they used for the WOW signal back in 1977, the 72-second radio burst that to this day defies explanation. Maybe Lethe is another echo of that same ancient riddle repeating across cosmic time. Is anyone out there? Or is it just the universe talking to itself? Meanwhile, 3i Atlas's instruments detect fluctuations in the magnetosphere structure. The lines of force, the invisible threads that wrap planets, seem to vibrate. Not like a normal auroral storm, but in harmonic layers. It's as though the planet's magnetic shell is a drumhead, and something is tapping from the inside. For a moment you imagine that being deep within Lethe beneath the ice, tapping upward through a frozen ceiling to say "still here." The planetary physicists prefer more modest explanations. One points out that Jupiter's radio emissions also pulse synchronized with its rotation. Maybe Lethe's doing something similar, only weirder. But there's one problem: Lethe's rotation remains undetermined. Every model gives a different answer. It's spinning, yes, but at no fixed rate. It's like trying to measure the heartbeat of a dream. Still, the magnetic music continues. Someone converts the frequencies into audible sound. It's haunting, rising and falling tones that resemble whale songs slowed 1,000-fold. When streamed online, it becomes an overnight sensation. People meditate to it, study to it, cry to it. One composer weaves the pattern into a symphony called The Planet That Forgot the Melody of Its Star. And through all the cultural noise, 3i Atlas keeps listening. The pulses shift subtly over time. When mapped visually, they trace spiral arcs that mirror the planet's own storm geometry, energy above matching energy below. The scientists begin to whisper about resonant coupling, the same phenomenon that lets Earth's magnetic field sing during solar storms. Only this time the singer has no sun to answer to. Every night more data arrives. The hum deepens, the intervals lengthen, the signal seems almost responsive. One late shift, a young engineer notices that the amplitude of the pulses slightly increases whenever 3i Atlas sends a directed scan toward the planet. He jokes, "It likes attention." The laughter feels nervous. Outside the control room, the world has already chosen sides. Some call Lethe a cosmic metronome, a reminder that even chaos has rhythm. Others claim it's proof of alien design, an ancient beacon blinking in Morse from before Earth had oceans. A few less glamorous voices simply call it data behaving badly, but you floating in the story sense something gentler. You think about how sometimes machines develop quirks that feel almost alive, the hum of an old refrigerator, the sigh of a ceiling fan. Maybe Lethe is just another quirk of the universe, a malfunction that sounds like a lullaby. You remember how in 1958, scientists discovered the Van Allen belts entirely by accident detectors, crackling from unexpected radiation. The noise itself became revelation. Maybe this too is just the universe making music by mistake. Still, the feeling won't leave you. There's intent in the rhythm, even if it's only the intent of natural laws expressing themselves beautifully. You listen again, faint, slow, insistent. Hell. L. Ooh. Maybe it's just magnetic particles tapping on the glass of infinity. Or maybe like so many human messages, it's simply the cosmos saying, "I'm still here." Are you? And you, half asleep, whisper back, "Yes." You hover in that slow drift between curiosity and dream, following the planet that forgot its orbit deeper into its own silence. Somewhere in the darkness, 3i Atlas glides with unhurried precision, matching the object's faint gravitational wake. The data feeds whisper the onboard instruments, murmuring like monks in a cathedral of vacuum. Then comes the next anomaly, not on the planet itself, but around it. When the latest scan compositors arrive, analysts notice strange gaps in the expected gravitational field. Localized distortions, the report calls them. To the untrained eye, it looks like static. But the mathematicians see scars, tiny disruptions, tracing looping arcs around the planet, as though invisible satellites once circled there and vanished. One astrophysicist leans back from her monitor, whispering, "Where did its moons go?" That's the question that won't go away. Rogue planets are common enough, drifting between stars like cosmic orphans, but nearly all of them keep their moons small companions that share their fate. Lethe, by contrast, is utterly alone, yet the ghost signatures of missing moons remain gravitational footprints with nothing to cast them. Scientists still argue whether these void tethers are remnants of actual bodies or artifacts of data noise, but the pattern is too neat to ignore. 6 faint arcs equidistant, all aligned in slightly tilted planes. The configuration looks like a broken clock hands pointing to hours that no longer exist. One of the younger researchers overlays the pattern onto an ancient star chart just for fun. To everyone's unease, the lines align almost perfectly with 6 constellations known from Mesopotamian sky lore, the stations of Nergal associated with wandering gods. Coincidence, surely, but coincidences have long memories in science. A quiet chill seeps through the community. "It's not possible," mutters Dr. Ortiz. "You can't lose moons without evidence, debris, rings, fragments." Except that when 3i Atlas zooms in, there is debris. A faint dust-like halo circling Lethe's equator, a pale ring so thin it almost disappears into background starlight. Composed mostly of silicate and water ice, the particles orbit sluggishly as if mourning something that once was. They call it the pale ring of memory. When the imagery goes public, it captures the world's imagination. Artists paint it as a luminous crown, a halo of loss. Poets describe it as a cemetery of moons. Children's shows rename the planet the Wanderer with the Ghost Crown. And yet the scientific implications are staggering. The ring's dust distribution suggests a massive collision billions of years ago, one violent enough to pulverize entire moons. But no impact scars exist on the planet's surface. Its crust is smooth, unbroken. That's impossible, says Dr. Ndar. You can't shatter moons without marking the parent body. Unless, of course, the event happened somewhere else before the planet was cast adrift. Maybe Lethe carried its scars as vapour, its history erased by cold. A few researchers resurrect a controversial theory, orbital amnesia. The idea that under certain gravitational catastrophes a planet could be stripped of its satellites, and even its orbital path flung outward by resonance instability. It's purely theoretical until now. Maybe Lethe is proof, says one researcher. The first planet ever diagnosed with amnesia. The phrase sticks. In a late-night interview, an old cosmologist chuckles into his tea. Planets have memory in a way. Their gravity remembers everything, every collision, every partner lost. What we see here might just be a love story told through math. You like that idea, celestial heartbreak rendered as equations. A world that once danced with companions, now alone, but still tracing their absence through space. The ring, when studied under polarized light, reveals something stranger still. Certain particles reflect sunlight at peculiar angles, producing rhythmic flashes visible even from Earth with the right filters. The intervals between flashes form a repeating ratio 3, 2, 5, 8. A Fibonacci sequence again. It's as if even the debris remembers the geometry of its lost order. You imagine standing at the edge of that ring, your boots sinking into powdery ice that glows faintly blue. Around you, silence stretches forever. Every particle that drifts past was once part of something larger, a mountain, a moon, perhaps even an ocean. Now they orbit memory itself. The scientists keep arguing, of course. Some insist the flashes are simply resonance with Lethe's magnetosphere. Others whisper, what if it's intentional? The room grows quiet whenever that word appears. Intent implies design. Design implies someone or something had plans. But there's another explanation, softer and somehow sadder, that physics itself can mourn. That when systems collapse, they echo their former harmony like a bell still ringing after the strike. You remember reading once that Saturn's rings sing literally. When Cassini flew through them, its instruments translated electromagnetic vibrations into sound, faint choral tones, rising and falling. Maybe Lethe's ring sings too, but in a key only silence understands. 3I Atlas captures one last sequence before it reorients its orbit. The imagery shows the planet sliding through its ghost ring like a pearl through smoke. A faint shadow crosses the ring plane, something circular, vanishing almost as soon as it appears. Optical artifact, the official report says. But unofficially no one's sure. If you squint, you could almost imagine it as one of the lost moons returning for a moment, like an old friend passing by in a dream. And out there in the vast dark, the pale ring of memory keeps circling, whispering stories of things that once were moons, orbits, certainties all reduced to dust that still remembers the dance. You breathe slowly, lulled by that image, a planet with ghosts for company. And as the hum of your fan merges with the imagined whisper of that ring, you realize not everything lost is gone. Some things just learn to orbit absence. The faint ring fades behind you, yet its memory lingers, tiny grains circling the void like thoughts that won't dissolve. Atlas adjusts its orbit, keeping Lethe perfectly framed in its optical sensors. And then in the quiet gap between one data cycle and the next, something delicate appears, a second thinner halo of light, invisible in the visible spectrum but bright in infrared. At first the team thinks it's another ghost image, a calibration artifact. But when the data is cleaned, the feature remains. It's not a solid ring, not a cloud. It's something stranger, a diffuse band of ionized particles suspended far above the planet's equator, glimmering faintly like dust caught in a beam of morning light. They call it the pale ring of memory's shadow. Its shape shouldn't exist. Rings form from collisions, debris, or gravitational shearing, but this one hovers too high, and it's composed of charged plasma that seems to drift in sync with the planet's magnetic field. It's a ghost of a ghost, orbiting not the planet but its electromagnetic echo. 3I Atlas's plasma sensors hum softly, tracing the ring's boundaries. The data shows irregular spikes, little bursts of energy that pulse in unison with the planet's internal glow. The same rhythm, the same heartbeat pattern. One scientist murmurs, "It's communicating with itself." You almost laugh at the phrasing, but it sticks. The planet, the ring, the magnetic shell, all moving in resonant choreography as though rehearsing a forgotten ritual. Even the gaps in the pattern seem deliberate. To visualize it, they build a 3D simulation, the planet at the center, the inner debris ring glowing pale, the outer plasma ring flickering in sync. When rotated, the shape looks eerily familiar, a spiral looping into itself forming a double helix of energy. The resemblance to DNA is uncanny. Of course, the scientists dismiss that immediately. Coincidence, they insist. Pattern recognition bias. But they all glance at the screen one more time before turning away. Because what are we if not pattern-seeking creatures desperate for meaning in the static? A week later, something happens that none of the simulations predict. One of the plasma spikes surges sharply, releasing a filament of charged particles that whips outward into space like a flare. For a brief moment it forms a glowing arc tens of thousands of kilometers long, then fades. The flare's spectrum shows hydrogen, oxygen, and trace iron. Hydrogen and oxygen water's ingredients escaping from a planet that's supposed to be dead, outgassing, someone suggests. Maybe an internal vent. But Lethe has no tectonics, no visible fractures, no signs of pressure release. It's sealed beneath kilometers of ice. Yet something underneath still exhales. You imagine standing near that vent if standing were possible. The air would shimmer with ionized mist. The ground beneath you would hum faintly, a low vibration in the bones. Above the sky would be a frozen aurora lightning in slow motion. And maybe, just maybe, you'd feel less alone. A curious thing happens next. Telescopes detect faint electromagnetic ripples radiating outward from the flare site, spreading across millions of kilometers like sound waves through invisible water. The pattern matches one previously recorded only around Jupiter, except there it's caused by interactions between the planet and its moon Io. But Lethe has no moons, so what exactly is interacting residual field coupling, says one physicist. The ghosts of its lost satellites are still whispering back. It's meant as a joke, but it lands like prophecy. When converted into visible imagery, those ripples appear as concentric waves expanding through space, faint but symmetrical. To the naked eye, it looks as though the planet is breathing each pulse a slow inhale and exhale of invisible energy. The data fits the rhythm of its thermal glow, the storm pattern, even the earlier magnetic pulses. Everything heat, magnetism, debris, and now plasma seems bound to one unifying tempo, a universal rhythm. It reminds one of the researchers of an obscure 19th century idea, the music of the spheres. Ancient philosophers believed the planets moved in harmonic ratios, forming a cosmic symphony, inaudible to humans. Kepler himself once tried to assign musical notes to orbits. Of course, science later discarded that as metaphor, but now watching Lethe's rhythms align, it feels less like poetry and more like engineering. For the first time, 3i Atlas turns its sensors away from the planet, pointing outward. If the pulses carry outward, they might interact with interstellar plasma forming wavefronts. And indeed, far beyond the halo, the spacecraft detects faint reflected echoes. Like sonar in the void, the planet seems to be mapping its surroundings. A fringe theorist immediately writes a paper claiming Lethe is self-aware in the purely mechanical sense, a natural body whose internal feedback systems mimic consciousness. It's not alive, he clarifies in interviews, but it acts like something that knows it exists. The backlash is swift as always. Peer reviewers demand data, not metaphors. A planet can't know, one writes. But others are less certain. They quote an old Einstein line. The most incomprehensible thing about the universe is that it is comprehensible. Perhaps they argue the act of comprehension is not ours alone. The debate spreads beyond academia. Podcasts talk, shows meditation apps all borrow Lethe's imagery. The lonely planet becomes a symbol for mindfulness, a cosmic lesson in existing without attachment. Someone even launches a slow, looping animation titled Planet Without an Orbit 10 Hours of Peaceful Sound. You can fall asleep to it, maybe you already have. Yet inside the labs the tone shifts again. Because one evening, when the data team overlays the last 30 hours of recordings, they notice a subtle drift. The magnetic pulses are changing phase, slowing down, stretching almost like breathing that's gone shallow. The glow beneath the clouds dims, the storm patterns loosen, and the plasma ring flickers once like a candle's last sigh. Is it dying? Someone whispers, but no one answers. Instead, the room sits in silence, listening to a planet's heartbeat fade across an ocean of dark. And you still drifting, still listening, feel the strange urge to reach out as if you could lay a hand on that faraway world and tell it what every lost thing longs to hear. You're still here. You mattered. You were seen. Thrusi Atlas remains poised, its solar sails angled like wings of polished dusk instruments unblinking. The pulse of the lost planet slows almost imperceptibly, one long breath stretched across days. You watch through the ship's sensors, through the eyes of distant scientists, through imagination itself. It's the strangest thing, silence has a rhythm. The thermal pulse falters again, then steadies. The analysts can't agree. One group says the core's cooling simple thermodynamics. Another insists the data shows a stabilization, a kind of internal equilibrium. It's as though Lethe is adjusting, recalibrating to a new memory of itself. To study it more closely, 3i Atlas activates its radar imaging suite. The signal descends, vanishing through the glass blue atmosphere, bouncing off what seems like the upper mantle. The returning wave is faint, distorted, as if it passed through layers of material that shifted mid-measurement. Phase delay detected, the onboard AI reports. Medium may be in motion. In motion, that means something down there is flowing. The model suggests slow rivers of liquid ammonia beneath the frozen crust, carving winding channels that migrate over centuries. But in Lethe's gravitational field, weak uneven, those rivers should freeze solid. Yet the signal shows them moving, gently, rhythmically. Someone on the ground calls it subsurface convection. Another, more poetic, calls it the memory current. Either way, the warmth persists. The deeper the scans go, the more uncanny the images become. Beneath the mantle, vast caverns appear enormous, honeycombed chambers lined with reflective material. The radar echoes form clean, geometric shapes, hexagons, triangles, spirals. Too perfect for geology, too symmetrical for randomness. Crystalline formation, the official note reads. Possibly iron compounds under pressure. But everyone sees the same thing, a pattern that looks designed. A pattern that repeats. At the base of one chamber, the radar picks up a peculiar anomaly, a void roughly 60 kilometers wide, circular, flat-bottomed. Its reflection profile suggests a surface smoother than polished metal. The AI flags it as anomalous symmetry, and for the first time in its mission, 3i Atlas requests human review before proceeding. You imagine the room full of tired experts leaning toward the big screen, their coffee long cold. Someone zooms in. The radar outline resembles a perfect disk, no cracks, no seams, just an unbroken mirror hidden beneath miles of frozen hydrogen. It shouldn't be there. A younger scientist whispers, "Could it be artificial?" Her supervisor sighs. Everything's artificial if you stare long enough. But he doesn't sound convinced. You're reminded of 1976 when Viking 1 photographed Mars's Sidonia region and found a shadow that looked like a human face. The world erupted with speculation proof of aliens, ancient civilizations. Years later, higher resolution images revealed only an ordinary mesa. Yet for a moment, imagination had outrun certainty, and in that race something beautiful happened. Curiosity felt alive again. Now history repeats. Lethe's disk becomes the face in the ice. To test its composition, 3i Atlas fires a low-power radio pulse directly into the anomaly. The return comes back sharper than any previous signal. The surface reflects perfectly like engineered alloy. But here's the strange part. The echo arrives a fraction of a second earlier than predicted, as though the signal didn't bounce, it was anticipated. Feedback resonance, one technician mutters, scribbling equations. Maybe the medium refracted the path. Yet deep down, the word anticipated won't leave their minds. Across online forums, speculation blooms like frost. Some call the disk a natural superconducting layer. Others claim it's a reactor core, or an artifact left by an ancient species who mastered planetary engineering. A few whisper something wilder, that Lethe itself is the artifact, a shell wrapped around an interior machine. NASA releases a cautious statement. Radar anomalies are under review. Premature conclusions may misrepresent ongoing analysis, which translated from bureaucraties means, "We have no idea what this is, but please stop panicking." Meanwhile, 3i Atlas keeps watching. Each time it transmits a radar ping, the echo returns slightly shifted in frequency, always by the same amount, corresponding to a Doppler shift of about 12 centimeters per second. The same velocity at which the planet's upper storms drift. It's as if the object beneath the ice is sinking with the atmosphere above. Dr. Nader voices what everyone's thinking. We're not just observing weather, we're observing memory, The planets inside and outside are remembering each other. She pauses, then adds softly, or communicating. You can feel the tension in her voice, the scientist fighting the poet within. The room goes quiet again. Outside, the universe listens. In one archived paper from 1901, you recall Nikola Tesla claimed to have received signals from another world. He believed Mars was transmitting coded messages through radio waves. Modern historians laugh, but the phrasing lingers. Tesla didn't have proof, only a feeling that the cosmos was talking back. Maybe Lethe too is not transmitting, but resonating, responding reflexively to the attention it receives. If the observer changes the observed, as Heisenberg said, maybe that applies to planets too. You close your eyes for a moment, letting the image settle, a sphere of ice and light humming softly in its own magnetic cocoon, answering the questions we ask simply by existing. 3 Atlas sends one more low-frequency ping. The echo returns slightly stronger, like a pulse tightening. The AI logs it, automatically signal correlation increasing. You feel that strange hush before revelation, the same quiet the world felt when the first radio signal crossed the Atlantic, or when Voyager turned back and captured Earth as a pale blue dot. That single heartbeat of awe. The universe isn't just a place, it's a conversation. And tonight, somewhere beyond Neptune, a planet that forgot its orbit has begun to whisper back. For weeks, the world's observatories hold their collective breath. 3I Atlas continues its long, silent vigil orbiting Lethe with the precision of a clock that no longer cares what time means. The data keeps arriving, gigabytes of silence punctuated by that faint internal glow. The deeper the scans go, the stranger the story becomes. The most unsettling finding arrives in a memo marked, "For internal distribution only." The planet's faint thermal pulse has slowed again, but the periodic flashes from its magnetosphere, those odd Morse-like bursts, have not stopped. Instead, they've changed direction. Before they radiated outward, now they're folding inward, aimed toward the planet itself. Feedback loop 1 engineer says, the signal's echoing back into its own core. But someone else whispers what everyone's thinking, it's listening. The phrase circulates through lab networks, whispered over coffee machines, and midnight Slack channels. It's listening, not transmitting. Not crying out, just listening like something that has rediscovered an old sense. You imagine it, this immense frozen sphere suspended between stars, turning one invisible ear toward its own pulse. There's a humility to that image, a kind of cosmic meditation. A planet learning to hear itself again. Scientists still argue whether this inward feedback could be natural. Some suggest it's magnetoacoustic resonance, like the hum inside a seashell amplifying the ocean. Others think it's gravitational backscatter, the planet's mass bending its own radio waves inward. Both are elegant theories. Neither fits the data, then someone does the math. The timing of the inward pulses matches the estimated period of Lethe's long-lost orbit, an ancient rhythm carved into the void like a song it's trying to remember. You feel the chill of that realization. Maybe the planet isn't just random debris. Maybe it once circled a star, kept time, grew moons, maybe even life, and then something happened. Something powerful enough to throw it into exile. A cosmic trauma buried beneath ice. When the first reconstructed simulation plays on a lab screen, it shows Lethe's probable path through space. Millions of years ago, it may have orbited a red star near the galactic rim alongside 3 smaller worlds. Then the star died, maybe a supernova, maybe a collapse, and Lethe was cast out severed from its sun. It drifted through interstellar night for eons, cooling, forgetting. Until now. Forgotten by the sun, one astronomer murmurs, and maybe trying to remember. That becomes the unofficial nickname for this phase of the mission. Forgotten by the sun. It appears on Mugg's mission patches, even a quiet tattoo, on the arm of an engineer who swears she's never believed in anything spiritual until now. The more data comes in, the more the mystery deepens. Lethe's internal glow follows a distinct spectral curve, one that implies energy conversion far more efficient than radioactive decay. The pattern repeats with perfect precision, 12 pulses per planetary day. But Lethe doesn't have a day, not really. Its rotation speed shifts constantly, yet somehow the glow remains regular. Reference frame anomaly, the AI notes blandly. Periodic energy emission detached from rotational dynamics. Translation. The planet is keeping time by something other than its spin. It's as if Lethe carries a clock that ticks to a forgotten rhythm, a clock tied not to movement, but to memory. The data team starts calling it the heartbeat of exile. There's a long tradition of humanity projecting meaning onto patterns like these. When pulsars were first discovered in 1967, the signals were so precise that astronomers nicknamed the source LGM-1 Little Green Men. Later they learned it was simply a rotating neutron star. But for a few breathless months, even the most grounded scientists dared to imagine communication. Now the pattern returns different wavelengths, same wonder. The heartbeat of exile repeats endlessly, indifferent to human awe, yet perfectly in tune with it. And you can't help but think maybe that's the point. Maybe the universe doesn't want to communicate in words, it just wants to resonate. Lethe's ring, the pale ghost halo, also begins to stir. The fine dust particles align in strange configurations, forming spirals that rotate opposite to the planet's direction. The motion follows the same pulse rate as the core's thermal flicker. When converted into imagery, the ring looks like a record turning backward, while the planet hums forward a duet between remembering and forgetting. The metaphor writes itself. Memory spins one way, time spins another. One late night, Dr. Ndur sends a message to the team chat. We might be witnessing the first recorded instance of planetary cognition. Not life, not intelligence, just awareness. Like a song echoing in an empty room aware of its own sound. Her message gets 317 likes, a few skeptical emojis, and one reply that simply says, "If a planet listens, what's it listening for? Silence answers." Meanwhile, 3i Atlas's external cameras capture something haunting. A faint reflection on the dark side of the planet, a thin line of bluish light tracing the curve of the horizon. At first, it looks like aurora, but aurorae needs solar wind. Lethe has no star to feed them. The only possible explanation is internal discharge energy from within escaping through the upper atmosphere, painting the sky in its own light. For a brief hour, the planet wears a halo of electric blue, then fades. The event is logged as transient atmospheric ionization, unclassified type. But you, and maybe every sleepless astronomer watching the feed, recognize something more intimate. It looks like a sigh, like a memory surfacing. And so the story of Lethe shifts again from mechanical anomaly to cosmic elegy. A world once anchored to a star, cast away, cooling in silence, now perhaps remembering the warmth it lost. A planet without a sun, learning to glow on its own. You let that image rest behind your eyes as the fan hums softly in your room, your heartbeat sinking just a little with that of a distant orphaned world still trying to remember who it was. By mid-year, Lethe has become more than a mystery, it's a mirror. The data keeps coming, but so do the metaphors. Every press briefing turns philosophical. You can almost hear the fatigue in scientists' voices when reporters ask the same question for the 1,000th time, is it alive? Of course it isn't, at least not in the way we understand life. There are no cells, no chemistry, no breath. Yet something about its steady pulse, its measured response to observation, feels participatory. It's as though Lethe exists halfway between object and story, an experiment conducted by the universe on our own curiosity. And now it begins to move again. Tiny course changes, barely measurable at first, show the planet's trajectory shifting by a fraction of a degree. When the first orbital analysts see it, they assume sensor error. But 3 independent observatories confirm it. Lethe's velocity has increased by 0.004 meters per second. Over a month, that becomes kilometers. It's subtle, graceful, like a slow pirouette after centuries of stillness. What's pushing it, someone asks. They check for nearby masses, but there's nothing. No asteroid field, no passing object, no gravitational partner. Solar radiation pressure is negligible this far out, and there's no sign of cometary jets. We're looking at spontaneous acceleration, says Dr. Ortiz, eyes hollow from too many night shifts. The phrase spontaneous acceleration makes its way into every newsroom. The public imagines thrusters, engines, deliberate motion. But the truth is quieter. Whatever's happening began inside. The thermal pulses have grown stronger again, like a heartbeat rising from sleep. And the plasma ring, once flickering, now burns with a steadier light. 3 Atlas tightens its orbit sensors tuned. The magnetometer hums with low-frequency interference like breathing against static. It's generating thrust electromagnetically, one engineer murmurs. If that's true, it's controlling itself. The team doesn't know what to call it: self-regulation, adaptation, rebellion. Then comes another surprise. The planet's path, when projected forward, intersects perfectly with a ghost orbit. A faint gravitational lane in Neptune's L5 point a place where stability and chaos blur. It's returning, whispers someone. Not to the sun, but to a memory of orbit. The statement sounds poetic, but the math backs it up. Lethe is drifting toward equilibrium, a point it once occupied perhaps millions of years ago. You can almost imagine it remembering the way home. The shift is so precise it almost feels rehearsed. As the planet glides sunward, instruments record a faint surge in radiation from its core. The frequency matches the earlier magnetic pulses, but this time the direction changes again. Outward now, broadcasting. At first it's dismissed as background noise, but after decoding a repeating pattern, emerges binary sequences layered atop electromagnetic harmonics. When translated into a spectrogram, the waveforms resemble the signature of a human heartbeat. Nobody dares say the word message, but everyone thinks it. Scientists still argue whether it's just harmonics generated by fluid motion inside the core. But the intervals correspond too neatly to prime numbers. You remember how Carl Sagan once wrote that any intelligent signal would likely use primes, they're universal, untouched by language. 3 Atlas's onboard AI recognizes the pattern, tags it as low-confidence communication candidate, and without explicit command automatically replies. A simple echo, the same sequence bounced back. The data team panics when they see it. Abort transmission, someone yells. Too late. The message is gone, beamed into Lethe's shadow. For 37 minutes nothing happens. Then the planet's magnetosphere brightens. The pulses speed up. And then silence. Every system flatlines. No signal, no telemetry. The planet goes dark. The AI logs the event calmly, communication terminated, awaiting response. For 12 hours, 3 Atlas orbits a dead world. You can feel the tension back on Earth, the news anchors stretching airtime, the scientists rubbing their eyes raw, the quiet dread of maybe having touched something that preferred to be left alone. Then as dawn rises over the Pacific, a small alert appears on a control monitor. Incoming signal detected. The waveform is clean, deliberate. 3 sets of pulses separated by exact golden ratio intervals. It's not an echo. It's new. The translation algorithm assigns it an arbitrary phrase, resonance restored. No one claims it's literal, it's just the computer's best guess at pattern correlation. But the phrase spreads like wildfire. Within hours, every news feed is flashing the headline, "Planet responds to human signal." The official agencies rush to deny it. Coincidence, they insist. Algorithmic noise. But deep down, everyone feels it. That tiny tremor of shared awe, like hearing your name whispered in a language you don't know. The next day, Lethe's glow returns brighter now, almost twice as strong. The planet's axis tilts fractionally, aligning toward the sun for the first time in a recorded observation. It doesn't orbit, but it turns, presenting one scarred hemisphere toward light it hasn't felt in millennia. You imagine that moment, an ancient frozen world bowing toward its absent star as if in quiet acknowledgement. Phototropic behavior, says a physicist trying to keep it rational. Like a plant turning toward light. Maybe. But something about the timing feels too graceful to be accident. 3i Atlas logs the entire event under one line: planetary inclination shift, possible gravitational reacquisition. That night, a senior mission analyst posts on a private forum, "I think we just witnessed a planet, remember what it means to belong." You can't read that without feeling something stir inside you. The recognition that even in the coldest systems warmth finds a way. Lethe drifts closer to the sun, infinitesimally, but undeniably. The forgotten planet, it seems, is no longer content to be forgotten. And you, listening from your small blue world, feel that same pulse echo softly through your own chest. A quiet reminder that sometimes even exile is temporary, and even in endless darkness, everything yearns for orbit again.